Hi everyone, it's Rob, and I just wanted to take a few minutes to talk to you about the time value of money. And we're going to work with simple interest for this, although the same concepts apply for compound interest. But let's start with simple interest, all right? So, why do we care about time? Well, it's really one of the more important concepts in finance. The idea that money has different values depending upon when we receive it. So if I offered you $1,000 today or $1,000 in 10 years, either one guaranteed, which one would you pick? Well, you'd probably pick the money today. Why would you do that? Well, you kind of have a sense in your mind that $1,000 today is worth more than $1,000 will be worth in 10 years. So there's some time value sense that we already have built in, right? So basically what that means for us in finance is we need to know when we're going to receive money if we really want to understand or appreciate the true value associated with that money. So imagine I'd promised to pay you $100 2 years ago and I missed that payment. And then you caught up with me today. You'd probably want a little more than $100 because $100 today isn't worth as much as $100 was 2 years ago at an earlier point in time. So you'd probably want maybe $110 or $120, something like that. You'd want to add some interest at a fair rate to figure out what I should pay you today. So that's the notion of the time value of money. The same value can have different amounts. So the same value as $100 2 years ago might be $110 today. All right. So if we want to add interest to calculate an equivalent value or a fair value at a later date, this is a formula that we use. S is equal to P times 1 plus RT. The maturity value is equal to the original principal times 1 plus the rate multiplied by the time. And if we want to go backwards in time and take away interest, so if I want to find out what's $100 today, what would that have been worth 5 years ago, for example? Well, $100 today can buy me a nice dinner. What would that nice dinner have cost 5 years ago? This is the formula we'd use for that. We want to get the previous value, and that's the maturity value, S, times 1 plus RT to the power of -1. So we've got a negative exponent here because we're going backwards in time. The earlier formula at the top of the screen here, there's no exponent there, but really that means there's a +1, doesn't it? And so when we go forward, we're going forward with a positive exponent. When we go backwards, the exponent's negative. And that's true all the way through finance. Let's have a look at an example where we want to calculate the equivalent value in the future. We've got Bill. He's supposed to have paid Mary $500 3 months ago, but he missed his payment and he wants to settle a debt today instead. How much money should he pay if they agree that 6% is the fair rate? So they've decided 6% a year is a fair rate. What would Mary be willing to settle with, and what would Bill think would be an okay amount? Well, let's draw a little timeline. On that, I've got 3 months ago and today. Today's always 0 on our timeline. $500 was originally due 3 months ago. We want to carry that forward or add interest for 3 months to bring it up to today and figure out what we should pay instead. That's going to be the maturity value formula. So there's the formula. Here it is with the numbers in place. And originally $500, carrying forward at 6% for 3/12 of a year. We're not going a whole year. We're only going 3 months, so that's 3/12 of a year. We worked that out, $507.50. And so if Bill paid Mary $507.50 today, they'd both be happy and they'd be done. All right. Now let's look at it going to an earlier date instead. Let's say Jane had promised to give Raj $600 in 7 months, and she's just received some unexpected money and wants to pay him back early. Okay? So what should she pay if they agree that 4% is a fair rate? She's paying him early, so she probably shouldn't give him the full amount because he can go and deposit what he gets today and earn interest, and that'll bring him up to the full amount. And same thing, she wouldn't want to give him $600 now because why would she? She could put her money in the bank, earn some interest, give him $600 later, and be better off. So it's going to be a little bit less, isn't it? Here's a timeline again. We got today and 7 months on this timeline. The $600 is due in 7 months. We want to figure out what we're going to pay today. Well, that's an earlier value, so we're going to solve for P. You can think of P as a previous value if you like. That may help, right? Here's a formula for P. We plug the numbers in there, 4% for 7/12 of a year. This is what we get. And if we calculate that on our calculators, $586.32. So sure enough, just a little bit less than the 600. Now Raj, he can go and put that money in the bank today, earn 4%, and he'll have his $600 in 7 months. So he's not hurt by this at all, as long as he thinks 4% is reasonable. And Jane, again, if 4% is a fair rate for her as well, she's not hurt either because they're really equivalent. She would be just as happy with $586 today or $600 in 7 months as her payment. Doesn't really matter to her. Let's look at multiple payments at the same time. That's where it gets a little bit more fun. Now we've got Sarah. She's originally promised to pay Fraser $600 2 months ago and another $500 in 3 months. But she missed her first payment and they got together and she agreed to pay $800 today plus the remaining balance in 2 months. So how do we figure that out? Well, we're going to use an interest rate of 7% to work everything out. That's presumably what they thought was fair. Let's set up a timeline and see if we can sort things out before we jump into the math. On there, I've got all the different dates that are going on here. She was supposed to pay $600 2 months ago, so that's the old part of the old deal. And I'll put that on the top of the timeline, the old deal. And then she's supposed to pay another $500 in 3 months. So those are the two original payments. We're not going to do that now. We've got a new set of payments we want to think about. I'll put those on the bottom so I don't mix them up. $800 today and some unknown amount in 2 months. We don't know what X is. That's what we have to figure out. Okay. Now, we need to pick a focal date to do our math at. And I'm going to pick 2 months. That's where X is. So that's kind of a good one to work with. It'll make my math a little bit easier if I do that. So now that I've got a focal date, I have to move everything to the focal date, and then I can do the math part. So 600 has to come forward, 500 has to come backward a month, and the 800 has to come forward 2 months. Then I can take the top, the old payments, and the bottom, the new payments, set them equal to each other, and solve for X. That's what I'm going to do. So the new should be the same as the old payments after we've done all of our time value calculations or accounted for interest. Well, what is the new? 800 carried forward 2 months plus X should be equal to 600 carried forward 4 months plus 500 brought back 1 month. All right. So I've moved everything to the focal date really, and I want to set them equal to each other. If I work out the numbers here, I get 809.33 plus X is equal to 614 plus 497.10. How do we solve for X? We'll just add up the numbers, subtract the 809. We get X is equal to $301.77. So she's going to pay 800 and then another 301.77. That's equivalent to the original payments that she had missed. And that's all we have to do. All right. Now, if you'd like to use this video, you're more than welcome to, as long as you follow the requirements under Creative Commons. No commercial, no derivative works. Otherwise, please feel free to go ahead and use it. If you're unsure about how you can use it or what the rules are, you can visit the Creative Commons website, or you can contact me as well. Thanks very much, and we'll see you next time.